Hassler here. I'm going to give you some notes on 4.9, finding that initial value, and then your guys' job will be to complete these notes and turn them in on Classroom. Okay, so we've been working with these indefinite integrals, and remember that indefinite integrals are when you are asked to find an antiderivative. So an indefinite integral would be the integral symbol f of x dx, and when I find the antiderivative, that's technically called capital F of x plus c. And so today we're going to talk about, what could that specific value of c be if I'm given an initial value or an initial condition. So it says an initial condition, given an indefinite integral, such as the one I wrote in pink, one finds the general antiderivative. And that's what we've been talking about or practicing. You can use the antiderivative and an initial condition. An initial condition is a given point, also called an initial value, to determine the specific c value for that antiderivative. So instead of finding the antiderivative and writing plus c, we're going to find the antiderivative, write plus c, and then continue by finding what that c value is, knowing a specific point on my function. So I'm going to do the first couple, and then your job will be to finish this. Notice that it says solve the initial value problem. An initial value is the same as being given an initial condition. Okay. So I'm told the derivative, and my job is to find y. So I'm told dy dx. So my first thing I'm going to do is I'm going to find y. And what that means is I'm going to take the antiderivative of 4x to the 7th dx. Okay. This is a polynomial, so I'm going to rewrite my function, add 1 to the exponent, divide by the new exponent, right? And then plus c, because I could have any constant. And if I clean this up, I get that y is equal to 1/2 x to the 8th and then plus c. And in class, this is where we would stop, right? In class, we would say, okay, I found my antiderivative, and that's my answer, and that's what you quizzed on. Today, we're not going to stop. So today, we get to continue on our journey, and we want to now find what that c is, okay? So step 2 is that we're going to use... and I'm writing into this space, so I apologize. We're going to use that given information, that given initial value or initial condition to find c. Okay, so here I go. If I know that y is equal to, this is what I found, 1/2 x to the 8th plus c, I'm going to replace my y and my x with these numbers. So y is 3. And x is 1, my job is to find c, okay? So I get 3 equals 1/2 plus c. If I subtract half on both sides, I get that c is equal to 2.5, okay? And my final step is going to be to go back and write this equation with that c value. That's a terrible color. We'll try the green. So y equals 1/2 x to the 8th plus 2.5, and this would be my final answer. Okay, so my final answer is going to be going back and writing that y function and including that specific value of c. Okay? All right, let's do another one. I'm going to do number 3. Okay? So let's see. Again, I'm going to start by taking, it's already set up for me. I'm going to take that integral, that indefinite integral. I'm going to apply my antiderivative rules. All right. So this time it's already set up in that integral. I'm going to add 1 to the exponent, divide by the new exponent. Right. I'm going to add 1 to the exponent, divide by the new exponent plus c. And so I technically get y equals 2x to the 4th, right, plus x cubed plus c. And notice that I'm writing this as y equals, because again, I have this given information where I have an x value and a y value, okay? And I need to be able to substitute those numbers into this function. Okay, so if y is equal to 0 and x is 2, my job is to find the value of c. All right, so 2 to the 4th is 16 times 2 is 32 plus 8 plus c, right? This gives me 0 equals 40 plus c, so c must equal negative 40, right? Just a little algebra here, okay? And my last and final step is that I'm going to go back and I'm going to write this function y equals 2x to the 4th plus x cubed minus 40. That was my c value. So I got to go back, write my original function that I found, okay, when I took the antiderivative, and fill in that number for c. So your job is going to be to do 3 and 4 following this process. 4 should be interesting. Pay attention to what is given to you for 4 and see if you can work through that, okay? Let me give you a hint, right? So you are given f double prime, okay? And you're asked to find f. Okay, so what you're going to have to do is you're going to have to go through this process twice. Okay, you're going to have to do the antiderivative of this f double prime function, and that's going to lower you down to f prime. Find that initial value, and you have that information to do it. Then you're going to have to do the antiderivative of this function, including that c. And that's going to get you down to f plus c, and you're going to use that information. Okay, so you have to go through the process twice. All right, down here at 5 and 6, I just want to throw this review in here at you. This is find the absolute extreme value. And so just a reminder, this is EVT. This is where we found derivatives, set equal to 0, define critical values, used a table to evaluate the function. Yes, without a calculator. And I'm just going to leave it at this. You have notes on this, right? And so it's your job to go back and look at your notes and see what you can do. So your job is to finish this paper to the best of your ability and turn it in. We will go over it when we are back in person all together. And if you have questions, feel free to email me.